Hey guys, we got a Motorola model number VPN1013A. This thing's 120 volts, 60 hertz, 3.5 amp. Output 13.8 volts at 8 amps constant duty. So that's the label right here for anybody's reference. So this one was dropped off last night by a friend of mine. Had some work done on it, and well, it needs a new AC cord, definitely, 100%. It's also got this DC modification hole drill in the front with no grommet. Like, why? Yeah. So let's take a look at the inside of this thing. Already got the screws out. So this is the inside of this here power supply. I have a big hefty electrolytic here. She is 25,000 microfarad, 40 volt DC. That's a whopper. Then we got the transformer right here. Circuit board, probably for regulation or whatever. We have the bridge rectifier right here. And terminals for ins and outs and whatnot. And this thing here is something somebody else put in, and it goes to right there. They're tied into other existing wires. One there, one down there. I'm assuming he probably goes to this plug here. We'll find out in a little bit. Then we have this terminal strip that's quite bent. But in any event, I got to put some kind of a DC output on this thing, because this plug here is no good to them. So I'm going to put a couple of binding posts on it, like I got here for the high voltage power supply that I'm still working on. But I've got another one similar to this one that I modified there a while ago. I'm not sure if I've done a video on it or not, but anyway, I ended up putting a terminal strip on the front of the power supply, and I ran the wire out. Well, it already had a cord, but I ran the wire from the cord up to the terminal strip, and then just used the terminal strip to power up whatever. It's the easiest thing to do with this. Get rid of this conglomeration here. Get rid of that. Put a proper grommet in there and run the DC feed out to the terminal strip. Figure out where these wires go, which I'm almost certain they're probably going to this plug. If they are, I'm just going to remove these wires here altogether. This one and this one. And then I'm going to run individual wire from the terminal strip directly to the terminal strip here. And while I'm at it, one thing I don't like about this is how close everything is coming to the cabinet on this thing. It's like really, really close. It wouldn't take much for the. It wouldn't take much to cause a short here. Definitely on the AC. I mean, you push in on the on this power supply on the side. It is too much. And you got two terminals here that would short out. That's your AC from your transformer. Your secondary and the transformer is right here. Wow. Wouldn't take too much to short them out against the chassis of the power supply. So I think I'm pretty sure I have some insulating material that after doing what I'm going to do with this, slide in on back of here to keep this from, you know, being a potential fire hazard. I would say at one point this power supply probably did have some kind of insulating sheet here, especially, you know, a corner piece to protect all this from shorting out. But it sure is not one there now. And the power supply is quite filthy, as you can see. I don't know what kind of life it had or where it was used, but the heatsink shows a lot of corrosion. That leads me to believe she was in a pretty damp environment. Damp and dirty. Anyway, let's see if I got a terminal strip to put on in front of this and get her done. But, first, how much room do I got here? I got a bit of room there. Get a terminal strip in there. No problem. Provided I get that open spot right there. See from in here. So that would be right basically right where the name is here. This is where terminal strip would have to go. Right here. So anyway, well let's see what we come up with here. Okay, so anyway, I replaced the AC cord. An old computer power supply AC cord. Grounded one. Use the same grommet. Comes up. That's neutral right here. I now have it heat shrunk. There was like one of them crimp joiner butt connectors, whatever. Anyway, soldered and heat shrunk here. I have a new ground put on here, and the hot, which is this black wire in here. Not this one, but this one here. There's the hot. I have insulation put on around the wire there, and got this terminal put on the front. The center is not connected. Center is no connection whatsoever. So right side is negative, or I should say left side is negative, right side is positive. So that's positive, that's negative. And of course, all you do is follow the red and the black wire coming out of here. I have a plastic insulator put here. I was going to put a grommet in there, but I couldn't get one that would fit proper, so I had this plastic grommet from a computer power supply. So I use this here, and tie wrapped everything down tight. I removed the old wire and the old plug and crap that was on it, and I cut the front connector. That was no good to me. Didn't want it, so I just disconnected the wires, cut off the wires here, and removed the red wire that was coming up here and had the tape on it. Removed that whole wire. The same thing with the black that was over here. Same thing. So there we have it. And I made this little note to this is the insulator that will be sitting inside the power supply to help isolate all the wiring and, you know, bare connections, especially, you know, the bridge rectifier down there. So that's my notes on it. Done this on May 28th. This is number 1. I said I replaced the AC cord as it was dry rotted. Yeah, it was definitely dry rotted. So, and I asked him when the last time this power supply was used, and he said about a year ago. And I'm like, well, you're lucky you never burned your house down, because that is bad. And if that wasn't bad enough, this is supposed to be a 220 volt or a 120 volt 5 amp power supply, or a 5 amp fuse in here. Well, somebody in their great wisdom decided to put a 20 amp fuse on the AC cord. 20 amp fuse. Think about that for a minute. Your AC plug in your wall is only capable of producing 15 amps, and they've got a 20 amp fuse put in there. Yep. You can say that again. This would literally have a meltdown. The circuit breaker panel in the house would have to trip before this stopped, before this caught on fire. This was a complete fire hazard. So, I made notes that I put on this piece of plastic. 1, I said I replaced the AC cord, dry rotted. 2, installed terminal strip outside front, which is this white one here. Disconnected the 6-pin plug, remove wire from the strip, which is the strip and the wire is down there cut off. Number 4, installed new hookup wire to the front power strip, which is red and black. Replace a 20 amp fuse with a proper 5 amp fuse, it's supposed to be there. And installed this plastic insulator. And when I hooked this thing up, I didn't just plug it in the wall. I used my Variac over here and checked the voltage output on this thing. So yeah, sometimes it just makes you wonder what people are thinking, because this could have very easily caught on fire and had a meltdown. Not good. Not good at all. So yeah, if you've got issues with power cords or anything like that, you should get somebody that knows what they're doing to replace it, and to replace it properly. And never overrate your fuse holder. Never overrate the fuse. If it says 5 amp, replace it with a 5 amp, not a 20 amp. Wicked. Anyway guys, hope you enjoyed the video. 7-3, and we'll chat later. This is Radionuts 63.